All right, so we've arrived. We are almost done with this chapter. So 11.6 is all of our optimization type problems. If we were in class, we would have 3 days of it. I believe we only have 2. Let me double check our schedule. Oh, we do have. Okay, so we do have 3 days of it. So I'm going to give you several different types of optimization problems. They all have the same process. It just depends on what you're looking for. Okay, so this first one is going to be on area and perimeter. So one thing that we need to remember is to find area of a rectangle. Your formula is length times width. Okay. To find the perimeter of a rectangle is 2 lengths plus 2 widths. All right, so area, it will say you're going to be finding dimensions or you're going to be finding the maximum area. Okay, so let's start with the first question. The first question says, find the dimensions of a rectangle with a perimeter of 76 feet that has a maximum area. So we're going to go through this as a process. All right, so the first thing that we want to do is we want to draw a picture. All right, now sometimes we can draw a picture, sometimes we can't. So in this case, we can draw a picture. So we have a rectangle. We're looking for the area, the maximum area, when the perimeter is 76. So the second thing that we're going to do is we are going to find the objective. In other words, what are we looking for? So always read the question first, and then going through this process will help you pull out all the required information. So let me read it again. Find the dimensions of a rectangle with a perimeter of 76 feet that has a maximum area. So our objective is maximum area. All right, that's our objective. We want to find the maximum area. Now, there's a second part to it because we're also looking for the dimensions. But once we find the maximum area, we're going to be able to find the dimensions fairly easily. So with this one, the objective is area equals length times width. All right, now we're going to use other variables other than x and y. X and y, unless it is already set up for you with x's and y's, if it's not already set up and we're using formulas like area equals length times width, use the same variables, okay? All right, this next thing is find a constraint. So this is where our domain comes in, okay? Everything that you do has limitations. If you're a business owner, you have only so many employees. If you are manufacturing something, you only have so much material to work with. Your machine only has so many ways to produce a product, or it can only produce, say, 20 products in an hour or 10 products, in a day. So you're always going to be dealing with constraints. The biggest constraint is money. You only have so much money. You do not have unlimited funds to be able to run your business. So there's always going to be a constraint. Well, every single optimization problem has a constraint already set within the problem. With this one, our constraint is our perimeter because it tells us we only have so many feet within our perimeter. So when I draw this picture, I have lengths and I have widths. Okay? So my constraint is my perimeter is 76 feet. So 76 feet equals 2 times length plus 2 times width. That's my constraint. That's what's going to limit me in terms of what my maximum area is. I don't have an unlimited amount of length and I don't have an unlimited amount of width. Okay, so objective, write your objective function first, then write your constraint. Okay, so now we're going to go from here. So once I find my constraint, I'm going to solve the constraint for one variable. All right, so if you notice, I have two variables. I'm going to pick one of the variables and solve for it. So I'm going to pick length. So I'm going to subtract 2w from both sides. So I get 76 minus 2w equals 2 times L. Divide both sides by 2. So I get L. Half of 76 is 38. 2 divided by 2 is 1. So this, and I'm going to mark it, that is my constraint. My length can only be 38 minus whatever my width is. Okay, that's what's limiting me on how big my area can be. Okay, so once we find our constraint, you're going to solve for one variable, and then what you're going to do, then you are going to plug the constraint into the objective. So that is our fifth step. Plug the constraint into the objective. Okay, so I'm going to do that over here. Oh boy, I'm running out of room already. Okay, so here's my constraint. I'm going to plug this into my objective. So my objective function is area equals my length is 38 minus w times my width. So I still have my objective, length times width, but now my length, my constraint is plugged into the objective. Okay, so here, from here on out, you guys are golden. We have area in terms of w. Okay, so I'm going to rewrite this area in terms of w. I'm going to distribute this w through. Okay, and now I have my original function. So find the objective, find the constraint, solve the constraint for one variable, and then plug the constraint back into the objective function. Okay, so now what you've gotten is your original function. Now we have something to work with. Okay, what we don't have is our endpoints. All right, so remember with absolute value or absolute max, absolute min, we had to have endpoints. So what we're going to do is we are going to find our endpoints or the domain. Okay, so we're going to do that using our constraint. We are going to set the constraint to equal, no, I'm sorry, to be greater than or equal to 0. Now, why is that? Well, because we're doing these optimization problems, they're real life application. So you are not going to have any negative numbers. So what we're saying is our length and width can only be positive. We cannot have a negative value when we're dealing with length and width. So remember, when you have greater than or equal to 0, what that means is we're dealing with only positive values. Okay? So we're going to take this value right here, this constraint. We're going to set it to greater than or equal to 0, and then we're going to solve. So I get negative w is greater than or equal to a negative 38. Then I'm going to divide both sides by negative 1 because I want to get rid of that negative. So remember, with inequalities, the minute you divide by a negative, it flips the sign. That's going to be really important. It flips the sign. Okay? So I can get rid of all this. All right. So here's our endpoints. Our endpoint is going to be between 0 and 38. That's what it means. So those are our endpoints. Okay? So now we are right back to finding absolute max, absolute min. Okay? So we have our original function. We have our endpoints. Now we're going to use our original function and find our critical points. Okay? So we're going to, let's see. I'm trying to get this so it's all on here. So number 7, we're going to find critical points. how do you find critical points? You find your derivative, set the derivative to 0, and solve. All right, so there's our original function. I'm going to find my derivative. Drop that 1 to the front, 38. Drop the 2 to the front and subtract. There's my derivative. I'm going to set my derivative to 0 and then solve. Divide both sides by -2, and I get my width is going to be 38 divided by 2 is 19. Okay, now I did erase it, but remember I had boxed this in. This is my constraint. I boxed it in because I'm going to go back to it. I'm going to use it again. So if my width is 19, I plug that into here to get my length. Okay, so you find your width, you find one of your variables, you plug it back in to get your length. So the length is 38 minus 19 is also 19. Okay? So we found our critical points. Our critical point was 19. We plug our critical point back into here. Okay, and now we're going to double check everything. We're going to, just like we did with our absolute max, we're going to take our, oh my goodness, I don't know where to do all this. We're going to take our endpoints. Okay, so our endpoints was 0 and 38. Our critical point is 19. We're going to plug that back into the original function and see which one is going to give us the maximum area. So we have a of 0, we have a of 19, and we have a of 38. Okay, so from this point on, after you have found your endpoints, and you find your endpoints based on the constraint, then once you have your original function, then it's just exactly what we did with absolute max, absolute min. You find your derivative, you set the derivative to 0 and solve. This is our critical point, okay? And then we plug our critical point back in to find our other variable, and then we're going to check. You have to check. So before you plug your critical point into the constraint, I would check first to make sure that the critical point is going to be the max, okay? A hint, most of the time it is. Most of the time, not always, but most of the time. All right, so here we go. I'm going to plug 0 into my original function. So I have 38 times 0 minus 0 squared is 0. Now, what does the 0 represent? The 0 represents my width. So when my width is 0, does that make sense? My area is 0. So I have no width. Okay? So it should make logical sense. Now I'm going to plug my 19 in. So 38 times 19 minus 19 squared is 361. And now I'm going to put in my 38. So 38 times 38 minus 38 squared. And that also becomes 0, which makes sense. If my highest value is 38, and that's what my width is, my length has to be 0. Okay? So it's kind of like when we drew the picture, you know, we have a couple different options. But if my width is 0, my length is going to be 38. If my width is 38, my length is going to be 0, because that's the highest it can be. We've used up all the values. Okay, so this tells me that my maximum area is 361. Boy, this is a mess. My maximum area is 361 feet squared. My width is 19, and my length is 19. So the dimensions is a 19 by 19. 19 feet by 19 feet, I get a total of 361 square feet. Okay? So let me do one more using area, and then we'll do the next kind.